everybody, this is Larry. This is day 2 of the Leetcode Day Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. Hope you enjoyed the intro I had. Hope you enjoyed the intro. That's it, I guess. I was in Colorado last week now, but still putting some clips together. So for the next couple of days, there may be some intros, so hope you don't get too scared about it. Today we have today I went 5 miles as part of my training. Yesterday I went 4 or 5 miles as well. It is ramping up and it is very tiring. I took a nap, it felt great, but I need more consistent sleep, to be frank. And I think one thing that, and maybe some part of it is that I'm getting a little bit older, so maybe this applies to you, maybe not, in the realms of Leetcode, but also running, because that's what I'm talking about, but in general, right? I think one thing that gets overlooked is recovery. I think when I was young, for sure, I could grind Leetcode all day, all night. I mean, I didn't, because they didn't have that back then, but competitive programming, I was grinding that all day, all night. Not for any reason other than that. I was just like it's just a fun puzzle to have, right? Puzzles, right? And it just kind of like, sometimes when you don't solve a problem, it just like gets in your mind and you can't sleep and you keep thinking about it. And definitely that was fine. But now, now a major part of what it is that I need to recover, right? Like, I can run as hard as I can, for sure. I could still do a lot of the things that I did when I was younger, but the next day is always a little bit suffering. There's always recovery, so I have to plan for it, and you have to sleep well and all these things, eat well, sleep well, just to even have a chance. So I think that's the same about Leetcode. I mean, at the end of the day, though, it's the same thing with running with Leetcode, right? Is that, look, if I'm like 1 minute faster, over like a longer period of time, like, I don't know, like if I get a little bit Leetcode in 5 months instead of like 6 months, then it doesn't matter that much. Honestly, no, not really, right? Unless you have a timeline. So definitely pace yourself, make sure you recover, make sure you sleep well, make sure you eat well, and do everything you can to get at whatever goal that it is that you want. I don't know that Leetcode is the goal that you want, but if it is, then go hard at it, right? Anyway, let's take a look at today's problem. We have 2561, rearranging fruits. You have 2 fruit baskets containing n fruits each. You're given 2 0-indexed integer array, basket 1 and basket 2, representing the cost of fruit in each basket. You want to make both baskets equal. To do so, you can do the following operation as many times as you want. Choose I and J, swap them, and then the cost of the swap is the minimum of those 2 things, which is actually an interesting thing. Already I have some strategies. 2 baskets will continue of sorting them according to fruit cost, mix them exactly the same basket. 2 baskets are considered equal of sorting them according to the fruit cost, mix them the same basket. Wait. Okay, I might have to go for an example. I don't quite know what that means, but return the minimum cost to make both baskets equal, or -1 if impossible. Alright, so I guess we have to figure out what equals mean. Equal is sorting them according to the fruit cost, mix them exactly. I mean, it just means that they have exactly the same elements. I guess this is a very precise way of saying, like, we sort them and they have the same number in the same order, which means that all the elements are pairwise equal or something like that, right? Okay, fine. And then you're trying to find a minimum cost or -1 possible. This reminds me of that classic problem, maybe not quite, but it reminds me of that classic problem of people crossing the bridge or something, not a bridge, a river, maybe I think there's a bridge version and a river version. Maybe that's why I'm confusing a little bit. What I mean by that is that, okay, you have, I think the bridge version is you have 1 torchlight, 4 people, they all have different walking speeds, only 2 people could cross the bridge at one time, and then you can't go back and forth or something. And then the river version is kind of similar, right? So something like that. But so it reminds me of that, but not necessarily whatever, right? N is 10 to the 5th. They're both the same size, so that means that we have no chance of doing something n squared. I think the first thing to note is that, and I talk about this a lot, about finding structure and creating structure, and one of these things with arrays is that whether there's an interesting structure, like in a sense that it can be interesting if you just sort either of these, or both of these in this case, right? And whether the ordering matters, order within the same basket matters, right? So the answer is probably no. So then we can immediately do something like this, and then because it doesn't change the answer, right? It just changes the order, but the order doesn't matter because you're swapping from one to the other anyway. Okay. And then maybe we can address the -1 first. And I guess the -1, and I don't know. And just to be clear, I don't know if sorting helps, or maybe it's not even necessary. But it is n log n, and n is more in, or I mean, I guess even if n is big, it doesn't matter, because if it's sorting n log n where the constant is so fast, it's going to time you out, then it's already going to be a bad time. But of course, you can always remove it later anyway. But and I say that because I think first now we can do something like we do a frequency table, right, from all the elements, and I guess in a reasonable way, if every element is if any element is odd, then we return -1, right? Then it's just impossible. Is that it? I'm trying to think real quick. What I mean is that, like, is that sufficient to say that every other possible is right? I think so, right? Because if you have the same elements, it may cost a lot of score or whatever it is. But I think that's it. I'm gonna get a water real quick. Sorry, friends. One thing about like taking naps is that you wake up dehydrated. And I woke up both dehydrated, and also I got this is not an endorsement. I mean, or it's not a paid endorsement. I got a lot of Sriracha favorite teas, and I just torn through it. It was very good, but it's very dry now. As a result, I'm very dehydrated. But okay. I think the min function that the swap function, which uses a min, is interesting, right? Because I think like and that's why I brought up the bridge or river problem, is because you can probably, or you should even, use the smallest element as whatchamacallit, right? As like a linchpin. I don't know what's the word, but it's the element that you just kind of go back and forth, right? Because I think like it's not necessary that I mean, maybe, right? So because there's a function that basically if you swap two things, then there are two well, I guess there are three scenarios, but one of them is dumb, meaning that one of the scenarios is dumb in a sense. Okay, there are three scenarios. The first one is that if you swap two of them, both of them started out of place. So when you swap of them, two of them are more in place than it was, right? So it goes from like let's say you have k things that are out of place and you have to fix. Well, now it's k minus 2. The other thing is, I want to say k is equal to 1 or minus 1. Maybe that's not even true. I don't even know if that is. It should be. Yeah, I mean, yeah, okay. I don't know if that's quite the right phrasing, but yeah, k minus 1, right? Where you only fix the location of one of the things. Maybe we have to work out how that works. But the other is, of course, the dumb one, which is just that it doesn't fix anything. And, maybe that's just silly. But yeah, and you'll never do that one because that just adds cost for no reason, right? So then now you have one that fixes 1 and then one that fixes 2. But it's not always clear that which move is better, right? But now we have a scoring function. It means that, which is that the cost. So you have two things you have to decide between, which is the cost of fixing two things and then the cost of fixing one thing twice, right? And what I mean by that is, I guess maybe it's a good time to use an example. Okay. Right, so now you have like to I don't know if this is a good example, but it's one to kick us off anyway. Oops. right? So here we swap the 2 and the 1 if 6 is 2 things, and that only costs 1, so that's great. But let's say, what is another good example? Let's just say this is maybe something like that. I don't know, something like this maybe. Maybe let's just go to hundreds, right? Then now, in something like this, you can say, well, you know, you want to fix 2 things at a time. Then we swap the 50 and the, well, let's just swap the ones first, maybe, right? So then now you have 1 1, 100 100 for the first half, and this costs 2, right? Because just 1, sorry. And then the second time you just do 150, and then that costs 50, right? So plus 50 to fix, and you have like 50, 100, or something like this, right? But of course, maybe the cheaper way is just to fix one thing twice, right? And what I mean by that is that, for example, now you can say, yes, so we swap, well, you have to swap one in the 100, so then now you have 1, something like this, right? And then now you swap the 50 in place, so that's at 1 cost. And then now you swap the 50 in place, right? So now you have 50, you have 1, right? And it costs 1. And then now we do it again. Oh, well, actually, I guess the 50 is done, right? But as a result, you can see that in terms of states, we already kind of cancel out these 2 at the cost of just 2, right? Of course, we have to make 1 more move, so that, you know, that's fine. But you can see that already it is, you know, cheaper, right, by a lot. And those are really, as we said, the only 3 possibilities. The third one doesn't even make sense for us. Like, for example, you could swap, I don't know, 100 and 100. It'll cost you, I mean, it just doesn't make sense, right? 2 things that are already, and it makes no improvement. So that's basically it. I do wonder if there's even a way in which this makes sense. Huh. I mean, maybe something like does this make maybe? Yeah, I guess because it's 1 plus 1 plus 1, so then in something like this, or maybe even, yeah. Then now if you try to do that this way, swapping the 149. And then swapping, and then now you have a choice of, we could even start it this way, but you have a choice of doing the 49 to 50. So if you do it this way, it'll be 50, 49, and then and then now we have to move the 49 back. So something like this, right? I keep hitting the wrong key, but and that's just no bueno, right? Because the alternative is a more straightforward move of 49 plus 50, right? So we definitely have to consider that. And yeah, let's get to it. I'm also trying to think. Okay, so those are the 2 examples, like a very constructed example to you know to consider both cases. I think the one then now is that, well, we have more than a lot of elements, right, to kind of match. So then how would we match them one at a time? I guess it is just a very stateful thing, right? Because we have the minimum element, we know what it is, and it has to appear in both sides by definition. And maybe, and also I wrote it this way, but maybe an easier state to start off with is just something like this even, right? Because then now it is more clear that, is this right? Yeah. Yeah, it's more clear that from here, then you have to swap 1 and the 50, and then 1 and the 100. Oh, oops. Right. So then you only make 2 moves, where the alternative is just swap 50 and 100, right? And then as a result, we can actually do like yeah, I'm already thinking about how to implement it and how to construct it, but I think the idea should be the idea should be fine and able to do. We just have to figure out, well, now how to actually do it, right? Yeah. And I think the idea that I would build on this, like, okay, so we have an example where we only use one, do one move at a time, but because every move, because all the operators are, or all the numbers are kind of built incrementally on each other, you can kind of just build them like almost like an inductive kind of way. And what I mean by that is just that, you know, like if you swap two things, then they're gonna be, yeah, they're gonna be now fixed, right? So then now you have the new state in which two more, or because so what I want to say is, sorry, I'm saying this a little bit weird. You could do it in a way such that you improve the states every time, right? But now instead of so we want to chunk it down to, like I said, having k things misplaced to k minus 2 misplaced. Instead of saying k minus 1 or k minus 2, we can think about it in terms of k minus 2 every time, but chunking it so that it takes either one move or two moves involving the smallest number. I mean, that's basically how I would break it down. Yeah, I'm just trying to think. It's still like a very awkward to write problem, I think. But yeah. But I think we can, okay, so there's this. Okay. And then, yeah. Let me also actually keep this as an example. Maybe I'll just put it, we'll delete it later. So I could use it, put in the test case. I guess actually we could just put in a test case now, right? What was it? Maybe that's a better practice. And then the other one of same thing. Oops. And because I think one thing I didn't mention is that there is this like locally greedy aspect that leads to a good global state. This will give us like a relatively linear-ish. I say linear-ish, it's probably going to be n-log. I mean, it is going to be n-log n, right? So, yeah. Okay, so we want to say, yeah. Okay, so it is a very awkward thing to write. So maybe F1 is going to be equal to collections like counter basket 1 minus and then F2 is just the opposite, maybe. And maybe we could have written this in a slightly cleaner way. But basically now, F1 contains all the extra elements that F2 does not have, or basket 2 does not have, right? And so forth. And it should, as a result, have 2 of everything, right? Everything that, oh no, well, it's a counter. So, well, I mean, it should be a even number of everything, otherwise you can't give it away, right? So then now, I'm trying to think whether we should do the min element first, so that so that we could get to the state where there's one of each min element, and maybe that's fine. Let's do that, right? So, oh, actually, we have to keep track of the min element anyway, right? I guess actually we don't need min element the same thing, but it is a little bit awkward for sure. Trying to think through. Sorry. Yeah. So min is equal to min of basket 1, or maybe just write like this. The min of the 2 baskets, and then this is our thing, right? So then now, how do I want to structure it? In a greedy way, I guess I'm trying to construct a case where you would do, um, where is it? Is it this one? Yeah. This input where you just make one move, right? This isn't the. It's just yeah. I think the input is actually 49. So then now you want to structure it so that it makes one move instead, right? How would you? Which way is the best? One move instead of the. I guess it doesn't really matter, right? Yeah, I guess it doesn't matter. Because I was gonna say like maybe I was trying to think like this is a very annoying problem to actually write though. That's what I'm thinking. I was trying to say that like maybe you would take like the min of available things on one side and then the max of available things the other side. I'm trying to think, does that matter? And the way that I try to think whether that matters is by some sort of swap principle, right? So let's say, I don't know, maybe there's another, now that we add another thing, let's just say 60, 60, and like, I don't know, something that just needs to be swapped, right? 59, 59. In this case, right, does it matter whether the 50s are tied to the 60s or 50s are going to 100 because right? I mean, in this case, it doesn't, but are there a case where that does, right? So for example, I don't know, let's say 55, and this is now 65, right? And this is how I come, greedy problems are really annoying and hard because of stuff like this, I think. But yeah, now 50, you clearly want, wait, do you though? Yeah, because if you swap 50 and 100, then you have cost 50 plus 55, but if you do 50 and 55, and you have to do 65 plus 100, so that's gonna be so do I want to sort the things in like a do I want to sort the things? Do I want to process this in order? I guess we can process this in order, right? Yeah, because then now we can say 50 and then we just take the max. But, well, I mean, yes, but we have to make sure that they're not on the same side, maybe? That's what I'm trying to think through. Like, if you have, like, this is a different state, right? Because then you cannot get rid of a 50 and 100 at the same time, right? Trying to do some math in my head. Sorry, this is a little bit tricky. I mean, I have an idea, but I'm just trying to think if I can prove it correct before saying a lot of wrong things, which happens from time to time. I think the thing is that here, you basically only do, well, let's say you have 4 numbers out of place. That means that you have to do 2 swaps, right? And I think if you do 2 swaps, it is just like 50 plus 55 always, no matter what side it is, right? Let's just remove this for now, right? And I mean, you could do the math of the min element, but because if you I think I get it. Excuse me. Jeez. I think I get it because of the pigeonhole principle. Because if here you have 4 groups of numbers, so you could just say even like the extra the numbers that we have to swap are going to be something like this, right? And those are our choices. And really, the only 2 possibilities, right, between because of the pigeonhole principle, we're only going to swap twice, or well, that's not the pigeonhole principle, but for 4 numbers you only swap twice, but because of the pigeonhole principle, that means that, or maybe the opposite of pigeonhole principle, that means that basically what I'm trying to say is that there's no way so that you're forced to not choose the minimum half, right? Like there's no way that to force 65 to be one of the smaller numbers unless you want to for some reason, because well, we only 2 cases, right? Without loss of generality is either this case, or you have something like yeah, right, which is to say either the 2 smallest number are in the same half or they're not, and if they're in the same half and you do the 50 and then the 55, and if they're not in the same half, you still do the 50 and the 55, and it will just match with one of the bigger numbers. You don't even care about which one really, and on which side it doesn't matter either, right? You just know that you're gonna do 55. You just pick a number that isn't in the biggest half, or sorry, that isn't in the smaller half. I guess that's the more critical part. So then yeah, and wow, this is honestly trickier than I expected in terms of just like going through all the cases, and then it is a little bit of case analysis is what I'm doing. Even though as we solve that analysis, you can reduce the case a lot easier as you go through it, right? Actually, do I need all this? Maybe. Also, maybe. I mean, this is a little bit unnecessary anyway. But yeah. Let's go consider. My naming is always terrible anyway. Alright, now for KV in F1 dot values, values are items. I always forget. I think values is just V's. But yeah, so then now for all the extra ones, we just want to, I guess we can just write what's it called? Something like this, right? To kind of, is it extend or extends? I always forget. Let's run it real quick. Yeah, that's why I was running it for, because I forget if it's extend or extends. I'll fix it later too anyway, but it's easier to do it now when my headspace is not deep into random things. Okay, so then now, yeah. Let's double check real quick. Well, it looks like it should be just, yeah, the key and the value, right? So then now, okay, right? Is that now we can sort, and actually this is pretty good because if we sort, the math is a bit trickier. Because there are 2 ways to do it. Which is why I'm saying it, because you can say that maybe it's fine. It's just more annoying. But I hesitate to kind of write complexity for no reason, especially one that is less robust. I mean, in production, I think you still want the better answer, but here, right now, this is maybe I would say premature optimization. And what I mean by that is that now has key and the value, right? But maybe it's okay to just have like the number of keys. Or like having duplicate, and the reason for that is just it's easier to do, right? Because otherwise I have to keep track of like what happens when you go over half, etc. So maybe let's do it that way then. Okay, I'm just being awkward. Right, and then for the in range something like this, which is very awkward to write, right? Something like that, right? So then now this is the just a list of regular numbers, right? Really? I mean, this is also like very not efficient, but that's besides the point. Or like, I mean, it's just extra constant operations. But you can see that the 1 and the 2 are the ones that we have to consider. And after sorting, we only need half of them, right? Because that's the number of things that we care about. So then, let's say M is equal to length of considers. and then what is it, right? So then now you have to score 0, 0, and then now for each number, we either, well, that's the score, or and this also gets rid of one big number, doesn't matter which one, right? Or the min times 2, right? Is it the min times 2? I think that's it, maybe, hopefully. Looks okay. That's good, because I mean, go low. Maybe I missed an edge case, actually. Maybe I should take some time. But yeah, okay, cool. 1950-day streak. Yeah, hopefully this was illustrative. I mean, I clearly did not have all the, like, I have the idea, right, in terms of what I wanted to do. But even then, honestly, the implementation is a little bit tricky to kind of work out. There's a lot of, like, you know, there's about understanding the problem, and then and even like getting the idea that, you know, you could use the min element twice or just swap. You know, that took a bit, maybe just to explain, but even then, like getting it to kind of going through all the cases, and that's the thing, is that like with deeper analysis, you're able to write code that is easier to understand, right? Because then now, for example, if you try to do some actual matching, it would be a lot complicated, right? Maybe not after you understand it, but well, after you made these observations in the same way, but if you try to do some matching about like matching the min and the max maybe, and what if the max is on the same side, then how do you match this? And like in theory, you could also greedy that out with a heap or something, I think, to be frank. Like if you have something like this, that's all the quote unquote extra numbers. You could probably put everything in the heap and it would work out okay. Because if one of and you could say, like, I don't know if it's pitch now, but you say that with one of the minimum numbers on the opposite sides, then by definition, the max is on the same side, right? Because you're basically saying that, yeah. And also maybe it even doesn't even matter, right? Which side is on. It's just that you have to swap them because you have an extra on that side. So maybe, yeah. There are a lot of ways to look at it, but definitely you have to work it out to kind of figure it out. Yeah, definitely a tricky problem. And then you can kind of write this in a not so kind of way, if you ask me. But yeah, let me see what I did last time. See, I mean, last time was 2.5 years ago. Got 2 wrong answers. Yeah, and like I said, it's very easy to make a silly mistake. I think it looks like I did. I mean, yeah, just want to go for it. Like this is what I try to do, right? When I maybe watched it during the contest or something, I constructed the left side. There's an extra one on the left side, extra one from the right side, and we just try to like see what's swapping. So we have a left and a right, and then we do a what you might call like a greedy popping off the left or the right. But apparently it's wrong. Even though, I mean, structurally it looks right. Maybe there's some greedy reason why that's wrong. Well, anti-greedy maybe, if you will, because you just swap with 4 and 5 and 4. At least this is easy to analyze. I actually don't know how you get 8. Oh, you keep on using the min twice, maybe. I don't know, right? But like I said, it's structurally. I don't know why sometimes you click on this one, it goes to one window, and sometimes the other. But in any case, yeah, and you could see me like getting it wrong twice, trying to fix it, and then. Did I fix it? Oh, so I mean, I did fix it. Oh, no. Oh, the heap thing. Oh, no. It's still using a deck. So maybe I just have some weird typo. But you can see that, like, with a case analysis way, like, it's still very easy to mess up. I actually don't even know what's the difference between these two. The wrong answer, the right answer. I'm not going to dig into it. But today we had a slightly better way of doing it. Oh, yeah. Huh. Wow. So Larry did figure out in the past where, I mean, I did the left and the right thing as well, but then I just kind of look at like, okay, and maybe that's in that video of just lining them up. Then it just kind of comes up. Actually, I have no idea how this works. This looks crazier than I do today. I mean, it still try to match them from the left and the right, but I don't know how I don't know. Maybe watch that video if you're curious about it. The answer is gonna be slightly different from today. But yeah, this does have a sorting component, though. I guess these two are actually not necessary, but this one probably is. Or you use a heap or whatever, so it's gonna be n log n. Yeah, and even if you use a heap, even if you want to say it's a min n over 2 heap, is still log n, right? It's just n over 2, log of n over 2. So anyway, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, hope you enjoyed the intro. Stay good, stay healthy to good mental health. I'll see y'all later. Take care. Bye bye.